Hi dear friends, glad to see you again today. A quick video about the Star of the Magi, also known as the Star of the Nativity. Last night I talked about this topic on Digi. I'll leave the Digi recording here and then I'll come back with more details.
Good evening. What do we know, Christian Presura, about what the sky looked like 2025 years ago?
We know quite a lot because we can simulate, we can see what the position of the Earth was, what stars were in the sky. The question is, what did the Magi see back then, whether the Star of the Magi is a legend or not? I'll let you write your thoughts in the comments here. I'm especially interested if there are any astronomical observations that support this hypothesis. Over time, several hypotheses have been considered. It has been said that it is a planet in a retrograde moment, meaning when its position in the sky changes, and for a short moment it stays roughly in the same apparent position compared to the other stars. It is also described as a conjunction when 2 or 3 planets happen to align at the same time. It has also been said that it is a nova or a supernova explosion, and it has also been said that it is a comet. This is the hypothesis I want to talk about in this video. The comet hypothesis was brought back into attention this year by Magi, a researcher who is at National Aeronautics and Space Administration. I looked at the article he published this year, and in short, I'll present something I found there. Essentially any event, astronomers who try to explain the Star of the Magi have to explain 3 things. The first thing is how the star appeared in such a way that it could be seen by the Magi. The second thing is how the star moved, in such a way that it guided them on their journey from Jerusalem to Bethlehem. And the third thing, how did the star stop? Precisely in the right places, in such a way as to show the Magi that Jesus was born there. The hypothesis that the Magi's star was actually a comet is quite popular because it seems to explain all 3 steps pretty well. This was essentially shown this year by Magi, who studied Chinese archives and discovered that the Chinese recorded a comet that appeared in the year 5 before Christ. Christos then identified, in the Chinese descriptions, all the elements that could help reconstruct the comet's trajectory. Then he did something truly special. He simulated all the comet trajectories that would have matched the descriptions from the Chinese archives. Here, for example, are the perihelions of all these trajectories simulated by the researcher from National Aeronautics and Space Administration. On the vertical axis we see the perihelion, which is the distance between the comet's closest point to the Sun, and on the horizontal axis we see the time, the moment when the comet arrived. We see a red dot there and we'll come back to it. So we'll come back to it because the perihelion of this trajectory is very, very small. In other words, the comet gets very close to the Sun. What's very important is that he had to select from all these simulated trajectories the one that best matches the biblical descriptions. And for that he says, let's go through the biblical descriptions a bit, see how he made the selection, and we'll start with the first one. I'll read to you from the Bible, okay? And when Jesus was born in Bethlehem of Judea in the days of Herod the king, behold, wise men from the east came to Jerusalem asking, where is the King of the Jews, the one who has been born? For we have seen his star in the east and have come to worship him. This is the first point out of the 3. If you remember how the wise men set out on their journey and where they came from. Well, the Gospel clearly tells us where the wise men came from the east. Why they came from the east, from the Orient, yes, and how they set out. They set out because we saw his star in the east. The first time I read this, I said it's a contradiction. Because if the Magi were in the east and saw something at their sunrise and left, then they should end up in India, because in India, or even farther, in China, that's where the sun rises from. For them, yes, so they should have gone toward China, they wouldn't have ended up here toward Jerusalem. But it also seems that the original texts interpret from the east differently, as they say it should be, meaning at the sunrise. So basically the Magi didn't leave toward the east, meaning toward China, but they left when they saw something special at sunrise. Well, and a comet could have appeared then at sunrise. Now we move on to point 2, the journey from Jerusalem to Bethlehem. Now the Magi arrived in Jerusalem, and here's what the Bible says. Then Herod, secretly calling the Magi, found out from them exactly when the star appeared and sent them to Bethlehem. He said to them, "Go and search carefully for the child, and when you find him, let me know, so that I too may come and worship him properly." Later we find out that Herod had hidden intentions. We move on, and they, listening to the king, left, and behold, the star they had seen in the east went before them. What do we learn from here? That in the second part, the Magi went from Jerusalem to Bethlehem, and the star they had seen in the east, so that star they saw then at sunrise, yes, how could it be anywhere else in the sky? It was going before them, now before them. What does it mean towards Bethlehem? And if we look at the map, we see that Jerusalem is more to the north and Bethlehem is more to the south. There is a distance of about 10 kilometers between them, which, well, can be walked in about 2 to 3 hours. That means the star that went before them, which they saw at its rising. Yes, it must have appeared to them in the astronomical south, so it must have appeared to the south, right? And that's the second clue by which the researcher from National Aeronautics and Space Administration selected, among all the simulated trajectories of comets, only those that would have met this condition. In other words, at that moment, it had to appear to the south if it was viewed from Jerusalem. The third condition is the most important one, and for that, let's read again from the Bible. "And they, having listened in the cold, left, and behold, the star which they had seen at its rising went before them." Well, until they reached Bethlehem, until it came and stood above, until the child was there, and when they saw the star, they rejoiced with great joy. "And entering the house, they saw the child with Maria," the key passage, "until it came and stood above where the child was." The first time I read this passage, I was amazed. That star should have been exactly above his head. To have arrived there and there, to have stayed as well, to have understood that this is the place. Anyway, such a description is very hard to justify astronomically. And then I read on the internet and found out that actually there is another interpretation of the text, which is more acceptable from an astronomical point of view. Well, and this third interpretation is connected to this description. Until it came and stood above, it stood, meaning it stood still, in the sense that it didn't move. In other words, that star was perhaps moving in the sky, in the southern area, to show the Magi that they needed to go south, to Bethlehem. But when they arrived in Bethlehem, that star stopped moving in the sky, meaning its apparent position in the sky stayed about the same. That's basically what it means by stood above, not above their heads, but above, somewhere in the sky, in the southern area, but it stood still, it didn't move anymore. Yes? That was the third criterion by which Mark Matney had to select, among all the simulated trajectories of the comets, exactly the comet that meets this criterion. In other words, if the comet moves across the sky at some point, that comet must remain roughly in the same position, maintaining its apparent position in the sky. And so, here are the three criteria in short, by which Mark Matney selected among the simulated trajectories of the comets. 1. It should be a comet that appeared around the year 5 AD, and that was visible in the sky at that time. 2. It should be a comet that about a month after it appeared, a month or 2 months, that is to give the Magi time to leave the east and reach Jerusalem. So, a comet that, 1 or 2 months after it appeared, would show up in the southern part of the sky in such a way that the Magi would have seen it and traveled from Jerusalem from north to south, that is, in other words, to have been guided by this comet during their journey. We can imagine that the comet might slightly change its position in the sky, but still remain in the south to guide the Magi to Bethlehem. And the third condition, actually the most important one, at some point the comet appears to remain in the same spot in the sky, and that's when the Magi know they've reached the place they need to be. And it has to meet this criterion. Essentially, we need a comet that, for a brief moment, has an almost geostationary orbit. What does that mean? Well, normally the Earth rotates around its axis. So if we have a comet here, and let's say it's approximately here, and the Earth is rotating around its axis, we will see during the day how the comet moves in the opposite direction in the sky. This drawing shows a comet in a geostationary orbit. What does that mean? Does it mean that the comet, comma, I forgot to say yes. It means that again, I can't put it without a comma. I don't have any data. Does it mean that's here's Earth rotating on its axis and here's the comet, right? If this comet has a speed that matches the Earth's rotation, then from Earth we will see the comet in roughly the same direction in the sky. That's what I wanted to show with this drawing from the article. Hey, and from here there's a very interesting calculation that I did here on CGPT. Why are we interested in this? Yes, for this comet to match Earth's rotation, but we know its speed is about 20, 30 or 40 kilometers per second. Yes, but if this movement is synchronized with the Earth's rotation, then it has an intrinsic relationship, which is given by the speed. It is equal to omega, the angular velocity, multiplied by r, the distance between the Earth and that comet, yes, then I can use this relationship to find out approximately what the distance to the comet is, because then I get r, equal to the speed divided by omega. And I know the speed, let's say 20-30 kilometers per second, I know the angular velocity of the Earth, which is, well, I won't say exactly what it is, so I don't say something wrong, but anyway, it is 2 pi divided by 24 hours. Yes, so I divide the speed by the angular velocity. Yes, and I get the distance, which is about 300,000 kilometers, meaning I get a distance roughly equal to the distance from Earth to the Moon. Simply put, here is a very strong condition for all those trajectories, which allows the National Aeronautics and Space Administration researcher to select the right trajectory. The right comet, yes. The condition is that the comet must have approached to a distance of about 300,000 to 400,000 kilometers from Earth. That is right there, about where the Moon is. Yeah. And we can see from this chart in the original article, right? The shortest distances of all the simulated Earth trajectories are drawn. The vertical axis shows the closest approach distance to Earth for that trajectory. And it's in astronomical units. Well, the astronomical unit is 150 million kilometers on the horizontal axis. It's the moment when that comet came. And we see that many of these simulations are clustered around the year AD. And that's normal because that was one of the starting points. And now we can make the final selection. Two together, looking at this graph, how? Well, first of all, we look at the horizontal axis. In the area around the year 5 Christos, we see there are a lot of points. For most of the points, the closest distance to Earth is on the order of astronomical units, meaning 150 million kilometers, which is very, very large. So we can ignore all the points at the top. We don't need a point that's very low on the axis. Yes, 300,000 kilometers means very little on this vertical axis. So it's definitely one of the lowest points, and that point is the red point, identified by the researcher from National Aeronautics and Space Administration. Well, and here we managed to identify, together with Mark Magny, the most probable trajectory among all the simulated trajectories, which matches both the descriptions from the Chinese archives and the biblical descriptions. What does that trajectory look like? And here is the trajectory of the comet. In the solar system, we see the Sun in the center in red, and in blue, the Earth's orbit. Yes, on April 1st, May 1st, and May 31st. We recognize two things here. The first thing is that this comet really does come very close to Earth around May 31st. In fact, the exact date is June 8th, so on June 8th, the distance between the comet and Earth was about 300,000 to 400,000 kilometers. And because of that, in the article, this comet is called the June 8th comet because that was the moment when the comet was closest to Earth. And this is very important for biblical history because if this theory is true, it is the date when the Magi, according to this hypothesis, arrived in Bethlehem to see the child Jesus. Why? Specifically June 8th? Because that's when the comet, as I argued, moved across the sky at the moment when it was closest to Earth. Synchronized? Yes, synchronized with the Earth's rotation. And that was the moment when it almost stood still in the sky and told the Magi, "Here is the child Jesus." But let me return to the chart where we see the comet's movement around the Sun. The second thing we notice is that this comet comes very close to the Sun. Well, and this explains the chart I showed you at the beginning, where I told you that the red dot, which identifies the possible trajectory that best fits all the events, that red dot is very low. On this axis, yes, because on the vertical axis we have the perihelion, the closest distance between the comet and the Sun, pay attention, and the Sun. And it's not in astronomical units, as you can see, but it's much less than 1 astronomical unit, 0. Something, yes, because this comet, as you saw in the previous chart, really gets very close, not only to Earth, but also to the Sun. Well, and here is, so to speak, the final chart, the final drawing, how it would have appeared in the sky at that time. This comet is an area in the sky, and we see the trajectory of the comet in the ecliptic space, because that comet, as you saw in the previous chart, moves in the ecliptic plane, and here we see the ecliptic plane, and the trajectory of the comet is shown in red. It moves from right to left. The dots represent the apparent trajectory of the comet for each day, and with a cross, the position of the comet was marked every 10 days, now having all the data of this selected trajectory for the hypothetical comet. I expected the author of the article to be searched for in modern databases. It is one that matches the simulation in the article, but it does not say that a known comet has been identified that matches the simulated one. Why do I think that way? A comet observed 2,000 years ago is very likely either gone today, fragmented, or in any case, deeply gravitationally disturbed. And the historical data is insufficient anyway for a unique identification. Let's take a look at this beautiful drawing which would show us the movement of the comet at that time. And let's conclude by thinking, was it like that or wasn't it like that? Well, what can I say? I didn't go into the historical details, which I suppose are quite a lot. I just wanted to tell you the story of this hypothesis which appeared this year, and somehow to get you thinking about astronomy too. Yes, in order to understand them, it was, so to speak, an astronomical exercise around Christmas, done by me in a hurry. Because I actually recorded this video before I went on Digi. On this occasion, I also prepared myself and a video that I probably won't edit that much, because I want it to be ready. Tomorrow evening, meaning December 25th, what can I tell you towards the end? First of all, happy holidays, and may you get everything you wish for in the new year. I want to thank everyone who supports me on Patreon. Don't go in, but if you do, I can even answer your personal questions there. I'm Christian Prasura. You guys are cool. All the best. Goodbye.